please subscribe to this channel. When you subscribe, you don't pay anything. To subscribe is for free. The aim for subscribing is that when the channel have got many people who view it, when we post things, those people, they get notified that we have posted a video, and it causes our video to reach many people. Then that assists us a lot. So subscribing is for free. When you have subscribed, you don't pay anything. Ladies and gentlemen, in this lesson 4 for vertical projectile, we will focus on treating previous question papers, trying to apply everything that we taught you in lesson 1, 2, and 3. I believe that treating a question paper is not to teach. So in lesson 1, 2, and 3, we were just teaching you the knowledge. If you have watched all the videos, surely you now have got the knowledge. So since now you have the knowledge, it means now we can apply the knowledge that we taught you. So I'm going to start by writing all the formulas here, the formulas for the motion, the formulas that we call the equation of motion. Then we are going to use them. The reason I'm writing them is so that as the question comes, we pick the one which is going to work for that question. And I think that will assist you to understand better. Vf is equals to Vi plus G, change in time. This is formula number 1. Formula number 2, Vf square is equals to Vi square plus 2, G, change in displacement. Number 3, displacement is equals to initial velocity Vi multiplied by changing time plus half G, gravitational acceleration, time square. The last formula, displacement is equals to the initial velocity plus final velocity, all divided by 2 multiplied by the change in time. Ladies and gentlemen, I will be treating questions with you, and I'll be choosing formulas here. And I'll be telling you that why am I choosing this one, not this one, when I answer question. Ladies and gentlemen, we may start. I'm using a document that is called Last Push. I'm using a document that is called Last Push, and that Last Push is a very good document which I can advise all the grade 12 learners to have. It is a good document in a sense that if you deal with projectile, it has got many previous question papers for only projectile. If you deal with work, energy, and power, it has got many questions for work, energy, and power only. You understand? So it becomes very good so that when you are studying, if on that particular day you will be dealing with momentum, you are just going to have questions for momentum only for previous years. So the Last Push document is very good. Okay, ladies and gentlemen, let us start. It's your teacher, Mr. Bila V. Today is the 19th of October. You are left with only 10 days, 2023. You are left with 10 days to write your final exam. And I'm here making videos to assist a black child so that you can go to the universities, you go to the world and compete there and make a good and a positive contribution to our society. So ladies and gentlemen, subscribe to this channel. This channel is meant for you. This channel can only grow because of your subscription. To subscribe is just to click the subscribe button. You pay nothing. It's for free. Thank you. Now I've displayed the question. Question number 7. I've displayed the question. I want us to read question number 7. Question number 7 is just a simple question. So I'm going to start from simpler question, then I go to complex. So question number 7, it is appearing on your screen. And question number 7 states that a ball is dropped from top of a building 20 meters high. Ignore the effect of air resistance. A ball is dropped from the top of a building 20 meters high. Ignore the effect of air resistance. 7.1. Define the term free fall. 7.1. Define the term free fall. I told you in lesson 1 that we've got two definitions, free fall and projectile. What is free fall? Free fall is a type of motion. So free fall is a motion. It's a motion under which the only force free fall is a motion under which the only force acting on an object is force of gravity. You can also write it like that, but I usually advise you to write what is in the exam guideline exactly. But the key words here are here. We've got what? We've got the only force. This word only, it must always be there. Then the word gravity, it must always be there. Then the motion must always be there. So free fall is a motion under which the only force acting on an object is force of gravity. So that is what we call free fall. Okay, so we won't dwell on the definition because that you can get from an exam guideline. I want us to deal with the calculation. We are told that we have got a ball which is dropped from the top of a building 20 meters high, and we must ignore the effect of air resistance. 7.2 says that calculate the speed at which the ball hits the ground. Calculate the speed at which the ball hits the ground. Okay. Remember, in lesson 1, when I was teaching you, we have a building. We have a building which has got windows, for example, windows. And this building is 20 meters. And the ball is dropped. Through the lesson 1, 2, 3, and this one is lesson 4, I've been emphasizing on these words, these English words. Remember, English is never our home language. We're just using it for teaching and learning. I've emphasized on the words to drop, to throw, to project. When you drop something, it means that the initial velocity of that thing is 0. Look at this one. You see what I'm holding now. When I drop, to drop is to let go. It means that particular thing is standing on this particular position, then I drop, I let go. When I let go, that thing, its initial velocity, this object, its initial velocity is 0. So it's very important for us to understand these words. The word to drop, it means initial velocity is 0. So what do we know? The question says a ball was dropped, so it means the initial velocity is 0. Then, the ball was dropped from what? From a 20-meter building. 20-meter building. So now, it means that we have most of the information that we need. We have most of the information that we need. The question wants us to calculate the speed at which the ball is going to hit the ground. And the speed at which the ball is going to hit the ground, that speed is the final velocity. Remember, initial velocity means the starting velocity. Final velocity means the ending velocity. Okay. We may choose a formula here. The formula that we want, it must have initial velocity, it must have final velocity, and it must have this displacement. But there is one thing that I want you to notice. We are not saying that it will need this displacement because we are simply given displacement. Sometimes in a question you can be given displacement, but you find that you cannot be able to use it based on how the question is asked. Look, the reason why we need to use this displacement. It is because this ball travels from its initial velocity until it hits the ground. Meaning that the ball is going to move from this position and end at this position. Meaning that any information that will start from this position and end at this position, we will need to use it. We cannot be able to use information of the ball that is above this height. You understand? So we are using this height because the ball traveled this height. You understand? The ball, if for example the ball was somewhere at the top of this height, then it fell down. We were not going to use this 20 because the ball did not travel this 20. It would have traveled this displacement and add this 20. So we're not going to use the displacement. But this time, we will use the displacement because the object, the ball, traveled from this 20 height and then it went down till it reached the ground. So we are bound to use this displacement because that is the displacement that was traveled by the ball. To be precise, I can say we can use the displacement because it's the displacement traveled by the ball. So the ball traveled exactly 20 meters. So we can choose a formula that have got displacement, that have got also the initial velocity. We can choose that one if we want. So let us check on these formulas. I'm reading the question again. It says a ball is drawn from the top of a building 20 meters high. Ignore the effect of air resistance. 7.2. Calculate the speed at which the ball hits the ground. We know that the ball initial velocity is 0. The final velocity, that's what we want to calculate. We know the height at which this ball traveled. We know the height at which this ball traveled. So now we are going to choose formula number 2. You can see we have formula number 2 here. Formula number 2 have got final velocity, initial velocity, and the displacement. Remember that this G represents the gravitational acceleration, whereby we will not struggle with the gravitational acceleration because it's a constant. It is always 9.8. So in order for us to calculate the final velocity of that ball, we're going to say Vf squared is equals to Vi squared plus 2g delta x. Remember that there is a mark for a formula. But what you need to notice, if ever you don't know how to solve it and you write the formula alone, you will not get the mark. You can only get the mark if you have written a formula and you try to write something. So in case whereby you don't know the answer, write a formula and write some numbers there so that you get the mark for a formula. So try to write something. So okay, let us solve that one. What do we do? The ball was going down. So we take down as positive. Down is positive. It means that anything that goes down, we take it as positive. Anything that goes down, we take it as positive. So here we're going to have VF squared. Then we have the what? The initial velocity. What is the value of the initial velocity? The initial velocity is 0. This is the velocity at the start. Why do we say 0? It's because they say the ball was dropped. To drop is to let go. So it means that the initial velocity is 0. Then we say plus 2. Then we come to the gravitational acceleration. If the gravitational acceleration is moving in the direction of gravity, of course. So it is always downward. And we have taken down as positive, meaning that even gravitational acceleration is going to be 9,8, not a negative. You understand? So now we come to the displacement. We come to the displacement. Also, we're going to have 20. We have 20. Then let us try to solve this one. Let us solve this one. Let me check my calculator. Then we will punch on the calculator and see what we get. Then we're going to have 2 multiplied by 9,8 multiplied by 20. You know that already we have the 0 there. Then VF square is going to give us 392. Then we put a square root, 392. We put a square root. Then VF is equals to square root of 392, which is going to give us 19,8. So what is the SI unit of the final velocity? Is 19,8 meters per second. Direction down. So direction is downwards. So now while heavy, we know that this ball is going to move from 0 meters per second, then it hits the ground at 19,8 meters per second. So now we can come and do the second question, which is 7.3. It says that 7.3 says that calculate the time it takes for the ball to reach the ground. Calculate the time for the ball to reach the ground. Let me write this answer here so that I can use it if I want. Okay, calculate the time it takes for the ball to reach the ground. So let's see how we calculate that one. The time it takes for the ball to reach the ground. Okay, this is what you need to think of when you are solving this 7.3. When they say calculate the time it takes for the ball to reach the ground, in other words, they're saying calculate the time the ball took to travel 20 meters. Calculate the time the ball took to travel 20 meters. So remember that we have information now. We have the initial velocity and the final velocity, and we have the distance that was traveled during this distance. You understand? We have the initial velocity, the final velocity, and we have the distance that was traveled. So now what we need the time at which this distance was traveled. So we look for a formula here that can either have initial final velocity, displacement, and time. Which one can we use here? Surely time must be there. Can we be able to use this one? Yes, we can, because we have displacement, we have initial velocity, time is what we are calculating. We can also use this formula. Can we be able to use this one? Yes, we can use it. It has got displacement, it has got initial velocity, final velocity, and the time. So we can use this formula and this formula. This one and this one can work. Also, this one can work. This one can also work. Even this one, all the formulas, they can work because we have initial velocity and final velocity. So we can use any formula. I can just choose to use the first formula because it is straightforward, the first formula. So I can say Vf is equal to Vi plus G change in time. Then final velocity that I have here is 19,8. Initial velocity is 0. G is 9,8. I took down as positive. It's 9,8. Then the time, that is what I'm calculating. So I'm going to have 19,8, which is equal to 9,8 changing time. Then if I want to solve for time, I'm going to what? To divide by 9,8. I divide by 9,8. So my time will be 19,8 divided by 9,8. And that will give me 2,02 seconds. So it means that for this ball to travel 20 meters, it took 2,02 seconds. It took 2,02 seconds. So we can even try to use another formula and see if we get 2,02 seconds. 2,02 seconds. So we can try to use another formula. Let us try it. Let us see if we are getting the same values. Okay, let me erase. All the formulas that have got the time there, they can work. Okay. Okay. Let me use this one, number 3. Delta x is equal to Vi plus Vf over 2 multiplied by change in time. Let us see. What is the displacement? Downwards is positive. The displacement is straight. What about initial velocity? 0. What about final velocity? 19,8. We all divide by 2. Then we multiply by 1 time. Then let's see. 20. This one is going to give us what? It's going to give us 19,8 divided by 2. 19,8 divided by 2. And that will give us 9,9 change in time. Then we divide by what? 9,9. 9,9 over 9,9. 9,9. Then changing time is going to give us 20 divided by 9,9. It still gives us 2,02 seconds. You understand? So we still get the same answers, meaning that, as I told you, we're in the right track. We can be able to get that using even the other formula. I hope you are following me on answering these questions. If you have some queries, drop the questions on the comment section. I will be able to get back to you and answer you. Okay, so let me erase this and we deal with the last question. So question number 7. Question number 7, it is not a complicated one. It's not complicated. And I think after this question number 7, we can do at least a more complicated question. Question number 7, what does it state? The last question. The last question says, sketch a velocity time graph for the motion of the ball. No values required. Okay. State the velocity time graph for the motion of the ball. No values required. Sketch the velocity time graph. No values are required. It is out of 2. So we can just make this. Then 0. You can have the time here in second and the velocity here in meters per second. So the question says that we must sketch what? A velocity time graph. A velocity time graph, no values that are needed. Okay, what did I say to you when I was teaching lesson number 3? Lesson number 3 and lesson number 2. It is about teaching graphs, that one. The graphs. What did I say? Okay, this is what I said. I said that as the object is moving down, the velocity is going to do what? To increase. As the object is moving down, velocity is going to increase. But the line that you are going to draw, it must be moving away from what? Away from the x-axis. Because the velocity is increasing. The line that we will draw, it must be moving what? Where? Away from the x-axis. You understand? So how are we going to draw that? It means the initial velocity is started from 0, right? It means your graph, it must do what? It must move away from the x-axis. So no need to show the values. So the graph is moving away from the x-axis. You understand? So that's how you draw that. If you take down as negative, it means you are going to draw your graph here. The graph is going to start from 0, then it moves away from the what? From the negatives. You understand? So that is the velocity. This is time graph which does not need values that were given. It starts from 0, then it moves away from the x-axis. They said that we must not put values, although we can be able to put values. If we want to put values, we can just do this. You can say the final velocity, it was that value of 19 something, the one which we got, 19 something, I forgot the value that I wrote here. Then the time at which the ball hit the ground, it was 2.02 seconds. So we can represent it like that. You understand? But the question says we must not include the values, so we're not going to include the values. Okay. Ladies and gentlemen, for question number 7, we are done. I want us to go to another question. I want us to talk about a question that is going to have a hot air balloon. Remember when I was teaching you lesson number 1, I was explaining what does the word projectile means. A projectile is an object that has been given initial velocity and it moves under the influence of gravitational force only. You need to write the word only, because if you do not write the word only, it means something else. You understand? So what does it mean? What does it mean? What it means is that whenever an object is falling, the only force which must act, it must be gravitational force only. So that is a projectile. Okay. Let me display question number 9. I've displayed question number 9 on your screen. It's about a hot air balloon. Let us read. It states that a hot air balloon moves vertically down at a constant velocity of 1.2 meters per second. A hot air balloon moves vertical down at a constant velocity of 1.2 meters per second when it reaches a height of 22 meters. Okay, let us take note of this thing. When it reaches a height of 22 meters and it is moving at 1.2 meters per second. Okay, let us take note of those two words. A hot air balloon moves vertically down at a constant velocity of 1.2 meters. When it reaches a height of 22 meters from the ground, a ball is dropped from the balloon. Refer to the diagram. Assume that the dropping of the ball has no effect on the speed of the hot air balloon. Ignore the air friction for the motion of the ball. Okay, let us start. Explain the term projectile. Explain the term projectile. I will not write it, I will just say it. you can read it for yourself. A projectile is an object that has been given initial velocity and it moves under the influence of force of gravity only. You must not forget to write the word only, because if it is not force of gravity only, there is another force, then that thing will never be a projectile. These formulas and everything that we taught you, it will not be true, it will not stand. So in order for whatever that we taught you to be true and to stand, the object must be a projectile, meaning that only gravitational force must act on an object. So to answer 9.1, projectile is an object that has been given initial velocity and it moves under the influence of gravitational force only. 9.1. Then we come to 9.2. I think 9.2 is interesting, we can write it. The question says that is hot air balloon free fall? Give a reason for your answer. Is hot air balloon free fall? Give a reason for your answer. So the answer is no. It is not a free fall. It is not a free fall. Why are we saying it is not a free fall? Because there are other forces other than gravitational force. Gravitational force acting on a hot air balloon. So a hot air balloon is not a free fall. And in lesson number 1, I've emphasized that if you have not checked lesson number 1, go and check lesson number 1 and watch it. I've emphasized that a hot air balloon is not a free fall, because a free fall, only gravitational force is acting on that object. So with a hot air balloon, it is not only gravitational force which is acting on an object. There are other external forces which are acting on the hot air balloon. So a hot air balloon is not a free fall because it is not only gravitational force which is acting on it. There are other external forces. I've given many answers, so I hope you heard them. A hot air balloon is not a free fall because there are many other forces, external forces that are acting. There is the air friction and other forces which are acting. So a hot air balloon is not a free fall. Okay. Let us come to 9.3. Calculate the time it takes for the ball to hit the ground after it is dropped. Calculate the time it takes for the ball to hit the ground after it is dropped. Here we are going to have a confusion, but let me clear the confusion because that's my work as a teacher. So now we have a hot air balloon that is carrying the ball, right? There is a ball in the hot air balloon. The hot air balloon is moving. Then a ball is dropped, meaning that, remember the word ball, the word drop, I told you that it means initial velocity. So this tells us that the ball did not have any initial velocity that was given to it. It was just dropped. But here we are going to use Newton's first law. Newton's first law, we say that if a net force or a resultant force, it says that an object will continue in the state of rest or uniform motion unless it is acted upon by a net force or a resultant force. Yes. I wanted to state Newton's second law. Newton's first law is that an object will remain in a state of rest or uniform motion unless a resultant force or unbalanced force acts on it. What does it mean? It means that since the ball was in the hot air balloon, The ball was also traveling at the speed of the hot air balloon. You can see they were told that the hot air balloon was moving at 1.2 meters per second. It means that since the ball was dropped, immediately the ball was dropped, the ball was also moving at what? At the speed of the hot air balloon. You know, when we were in grade 11, we explained to you with my colleagues, your teachers, this is what is happening. When we apply Newton's first law, we can explain in the scenario of a car. When a car is traveling, a car is moving at 80 kilometers per hour. Then the driver hits a dead brick. The people are going to move and hit the seat. The people who are carried by a car are going to move and hit the seat. Why are they hitting the seat? It's because the car has stopped, but the people inside the car, they are continuing to travel, and they are also moving at 80 meters per second. If the car was moving at 80 meters per second, for example, you understand? That is according to Newton's first law. So if I'm inside a bus that is moving 80 kilometers per hour, for example, it means even myself I'm moving at 80 kilometers per hour. That's why they say speed kills. Speed kills in the sense that if you are moving at a high speed, it means if a car is moving at a high speed, it means even the passengers are moving at a high speed. So when there is an accident, it means the passengers may hit anything that is there at that high speed, and that is going to reduce the time at which the force is going to act. Then there's going to be more injury. That is impulse. So now you understood, right? We understand that the ball was dropped, but the ball was dropped on a moving object. So when a ball is dropped on a moving object, the ball will be moving at the speed of that moving object it is inside of. You understand? It means that since the hot air balloon was moving at 1.2 meters per second, it means even the ball was moving at 1.2 meters per second. So it's not like we're changing anything from the word drop. We're using Newton's second law, Newton's first law, I mean. So now we may start. The question was asking that for us to calculate the time it takes for the ball to hit the ground. So what I love is that we have got the initial velocity, we have got the distance, we have got the initial velocity and the distance. Meaning that our formula, it must have initial velocity and distance. You understand? Do we have the final velocity? No, we don't have the final velocity. So we have got what? The ball traveled 22 meters because it fell when the hot air balloon was 22 meters from the ground. It means the ball traveled 22 meters and its initial velocity is 1.2. So we need to calculate the time it will take for a ball to travel 22 meters. So we check. This formula will not work. This one will not work. What about this one? This formula is going to work, this one. What about this one? This one is not going to work because it has got final velocity and we don't know the final velocity. So we are going to use this formula. We are going to use this formula. So we are going to say the displacement is equal to the initial velocity multiplied by the changing time plus half gravitational acceleration changing time squared. Then we take down as positive. Down, positive. We take down as positive. Do we have the displacement? Yes, we do have the displacement. The ball traveled 22 meters down, so we're going to have 22. What about the initial velocity? We understand that the ball was dropped, but the ball was dropped on a moving object, meaning that its initial velocity is the velocity of that moving object. So the ball was moving at 1.2 meters per second. Changing time, we don't know what is the changing time. That's what we want to calculate. Plus 1 over 2. In which direction is the force of gravity? The force of gravity is always downward, meaning that even the acceleration is going to be what? Downward. Gravitational acceleration is going to be downward. So we're going to have what? 9.8 meters per second. What about change in time? That's what we're calculating. So we're going to use this formula. So let us try to work it out. Let's see what we're going to get. We're going to have 22, which is equals to 1.2 change in time plus half of 9.8 is going to create our equation. That is 0.5 multiplied by 9.8 or 1.2 multiplied by 9.8, which is going to give us 4.9 change in time squared. Understand? So the only way to solve this one is to use the quadratic formula. The quadratic formula. So we're going to have what? 0 is equals to, let me arrange this like question 1. Question 1 for mathematics, solve for x. So I'm going to arrange it like that. So it means we're going to have 4.9 change in time. This one is like 4.9x squared. Then we're going to have plus 1.2 change in time, 1.2x, for example. Then minus 22. I just took this 22, took it this side. Then let us solve for t. Let us solve for t. We use our own quadratic formula. Actually, let me write. Change in time is going to be negative b plus or minus b squared minus 4ac over 2a. This is the quadratic formula, you know, right? By using it to solve it. So we're going to have negative, what is our b? It's 1.2. Negative 1 over 2 plus or minus 1.2. Negative b squared 1.2 minus 4. What about a? Our a is 4.9. AC is minus 22 over 2a, which is 4.9. So here we are simply solving for what? For change in time. So let me continue here. Change in time is going to give us, we know this because that's what we do in maths, and I know that you guys love that. 1.2 plus or minus. So remember that you cannot punch plus or minus on the calculator. So you're going to start by punching minus. You get the first answer, you come, you remove minus, you put a plus, you get the answer there. Yeah, that's how we do it. So we're going to have 1.2 square minus 4a, which is 4.9 multiplied by minus 22 over 2a, which is 4.9. So what do we get then? We get 2. We get 2. Then changing time, when we have a positive, we get 2. Let's see what we get if we have a negative. Let's see what we get if we remove the negative. This positive, we put a negative. Let us see what we have. We're going to have a negative 2.224. And we know that time cannot be negative. So it means we say time cannot be, we just write equal sign and we crash it to show that time cannot be negative. So it means that our change in time is going to be equals to 2 seconds. So it means that ball which was dropped from a hot air balloon, it touched the ground after 2 seconds. So I hope you understand what I'm trying to show you. Although the workouts that we're having here, they're not that much complicated, they're straightforward. I think now I'm going to give you a complicated example which is not straightforward, whereby we will have displacement but we cannot use that displacement for example. So that's what we will be doing. So stick around for the third example. Stick around. Okay, let us do the question that follows. That is 9.8. 9.4. Let us do 9.4. Let me display the question again on the screen so that you can be able to. Yeah, I made a mistake. I just erased the formulas. Let me just erase them and write them again. Okay? Because while these formulas. Number 1, number 2, VF squared, which is equal to VI squared plus 2G delta Y. 1, number 2, number 3. Number 3, and I noticed that I've been writing delta X instead of delta Y. Pardon me for that, you need to write delta Y. Okay. Delta Y, which is equal to VI, change in time, plus 1 over 2G, change in time squared. Then number 4, delta Y, which is equal to, yes, delta Y, which is equal to VI plus VF over 2 multiplied by change in time. I've been writing delta X. If ever I did that, I forgot. It is delta Y. If ever I wrote delta X somewhere, it is delta Y. Okay. Okay, ladies and gentlemen, let us do question number 9.4. It is out of 6 marks. It says, calculate how high the ball is from the ground when the ball reached its maximum height after the first bounce. So we heard that the ball was dropped from a water balloon. Here is the statement. It says, when the ball lands on the ground, it is in contact with the ground for 0.3 seconds, and then it bounces vertically up with a speed of 15 meters per second. So the ball was dropped, then the ball, it bounced off, it hits the ground, then bounce. I've always maintained that to bounce is when you return to the air. To bounce is not to touch the ground. To bounce is when you return to the air. We are emphasizing these words because English is not our home language. So we need to emphasize these words so that we can our learners can be able to understand them, because sometimes language becomes a barrier, but we're not here for that. We're here for physical senses. So to bounce is when you return to the air. So when you touch the ground, this is not bouncing. Bouncing is when you move off the ground. That is bouncing. So we are told that the ball then was in contact with the ground for 0.3 seconds, then it bounced. When it bounced and went up, it moved at 15 meters per second. When the ball lands on the ground, it is in contact with the ground for 0.3 seconds, and then it bounced vertical up with a speed of 15 meters per second. So the question says, calculate how high the ball is from the ground when the ball reaches its maximum height. So I can informally represent that. I say the ball was coming from the top, then it touched the ground, 0.3 seconds, then it went off. So it went off the ground by 15 meters per second. Then we know that the ball will later on fall to the ground to come back to the same position. So the question wants us to calculate how high is the ball to the ground when it is at its maximum height. You understand? So the question wants us to calculate this distance. How long is this distance? So let us calculate that. From theory, let me even represent that this is the first bounce. We are told that the ball went up and at 15 meters per second. What we know, is that when it returns, it will also be 15 meters per second. Although that may not assist us because that's not what we're looking for. We know that at the maximum height, we know that we're going to have 0 meters per second. So this is interesting, very interesting. Why am I saying it is interesting? I told you that when we use this formula, if we have initial velocity and the final velocity, this initial velocity and final velocity will give us ability to calculate the distance that was moved between them. It will not give us more than that. It will not give us the information which is at the top. This initial velocity and the final velocity will give us the distance between them. It will give us the time that was moved between them. You understand? So that's how we get to use this formula. That the initial velocity and final velocity will give us information between them only. It will not give us anything after them. So in order for us to calculate the time taken to move from this velocity to this velocity, we're going to use this. We cannot get more than that. You understand? So the interesting thing is that we know that we have this initial velocity and the final velocity, meaning that if we want the distance between them, it is easy to calculate the distance from here to here because we have initial velocity and final velocity. Also to calculate the time from this point to this point, it is easy because we have got the initial velocity and the final velocity. You understand? So now we can start to deal with the question. The question wants us to calculate the displacement. The distance from the ground to the maximum height. How do we go about that? What I know is that I'm going to need the formula that I've got the displacement, and I already know that it will give me a problem. Let us look. We've got three formulae that have got displacement. Is this one. This one requires displacement, initial velocity, which is 15. We have time is a problem. We do not have the time which the ball took from the time it bounced, the first bounce, until it reaches its maximum height. So it means that we will have a problem because this one requires time. Can you see? This formula requires time. Then this one does not require time. This one is straightforward because we have initial velocity, final velocity, and we've got displacement. So we can choose this formula number 2 because it does not require time. If we were to use the one which requires time, we're going to start by using this one. We calculate the time. After calculating the time, then we calculate the displacement. So this formula is straightforward. We can calculate the displacement without even using the time. Since we have this initial velocity and the final velocity, we will be able to calculate the displacement between them. You understand? We can be able to calculate the time between them. But this initial velocity and final velocity will never give us the time which is after them. You understand? So that is what is going to happen. Through this 5 meters, 50 meters per second and 0, we can calculate anything between them. You can calculate the displacement between them, you can calculate the time between them, because we'll be using 15 and 0. But if you were to calculate the time it took from the time it bounced, it went up until it reached, you cannot use 15 and 0. You need to use 15 and 15 because it will give you the time which was traveled between 15 and 15. That's how I think it's better to explain it. So now let us answer the question. Let us answer the question. So we are going to use formula number 2. As I told you that the final velocity and initial velocity we are trying to calculate the displacement. We're going to say Vf squared is equals to Vi squared plus 2g change in y. Final velocity. What is the final velocity? The object went up and reached its maximum height. At maximum height, what is the velocity? At maximum height, what is the velocity? So let us do this. Let us take up as a negative. Let's do that. Or up as positive there. we can take up as positive. I will give you an example where we're taking up as positive and down as positive. Okay. So final velocity. Our final velocity is going to be 0 because the final velocity, the object is going to start from this point where it is 515 meters, and when it reaches up, it will move 0 because it's the maximum height. So it means when there is v, we're going to have a 0. Then we've got vi, which is initial velocity. This is the velocity at which the object went up by, and it is 15 meters per second. We took up as positive, meaning that anything that is going up, we're going to take it as positive. So it means initial velocity we are going to write 15, because 15 is the velocity for going up. Then 2, then we come to gravitational acceleration. Gravitational acceleration, it is always 9.8 meters per second downwards. Remember, we took up as positive, meaning that's why we wrote 15 here, because that 15 is the velocity of going up. But what about the gravitational acceleration? The gravitational acceleration, it is always downward, meaning we are going to write negative 9.8. You understand? Then we are trying to calculate the what? The displacement. So that's it. So let us move forward. We're going to take this 15, it's going to come this side, it's going to be minus 15. Then we will have 2 multiplied by 9.8. 2 multiplied by 9.8. Then 2 multiplied by 9, negative 9.8, it is going to give us 19.6, meaning that we're going to have negative 19.6 delta 1. Then we divide by what? By negative 19.6, we divide by, no. This one is squared, guys. I'm sorry. This one is what? It's squared. It is squared. It is squared. It is squared. Sorry about that. It is squared. So let us correct that. That is 15. 15, let me correct that. I'm so sorry. I'm forgetting to see. It is squared, right? There we are going to have 15. We're going to have 15 squared, which will give us 222. So here we're going to have 225. Yes? 225, that will give us negative 19.6 delta y. I'm sorry I wrote 15 here. It is squared. Then we have negative 19.6. We divide by negative 19.6. Therefore, the displacement is going to be 225 divided by, it is negative, divided by 225 divided by 19.6, then it will give us 11.48 meters. So it means that the ball, when it bounced, it went up by 11.48 meters. So we need to choose another formula there and we use it. We'll see if we got the correct answer. Pardon me about writing 15 here. It is 15 squared. It is squared. Okay. So now I'm going to write the answer here. Displacement is equal to 11.48 meters. Then let me use another method and confirm if what we did is correct. Okay. And that will be also trying to expose you to another method of doing these things. I can just start by calculating the time, then I use this formula which requires the time and see if I do not get the answer. Let me do that. I'm going to use this formula to calculate the time. Vf is equal to Vi plus G, change in time. Right? Let me take up as positive. Up as positive, meaning where there is final velocity. Here I'm going to write 0. Initial velocity, I'm going to write 15. Right? Then I'm going to have 9.8. it is down, it is going to be negative, then change in time. Then the 15 will come this side, it will become minus 15, which is equal to minus 9,8. Change in time, I divided by 9,8, negative 9,8. Then my change in time will give me what? Let us see. 15 divided by 9,8. And that will give me 1,530612245. The reason I'm writing everything is because this is not the final answer. You do not round before you reach the final answer. Make sure that you don't round off before you reach the final answer. You can write it like this. You leave other numbers, but when you punch on the calculator, make sure you punch everything. We don't want you to lose marks because of such mistakes. Understand? So you do not round off before you reach the final answer. So it means the time the ball bounced and it went up, it took 1,53 seconds. Going up until it reached maximum height, it took 1,53 seconds. Why am I saying that? We use this initial velocity and final velocity. So this initial velocity and final velocity will give us the time it took to move between them. You understand? So now we can calculate the displacement. Displacement, we can use this the third formula, which is delta y is equal to vi change in time plus 1 over 2 g change in time squared. We do have now the change in time. Initial velocity we're taking up as positive, taking up as positive. Then initial velocity is going to be 15. Then the time is going to be, what did you get? It's going to be 1,53. So notice you can write it as 1,53, but when you punch on the calculator, you punch all the numbers. Then plus 1 over 2. Then the gravitational acceleration is going downward, meaning it will be negative 9,8. Then the time is 1,53 squared. Where they are this time, you punch everything, do not omit any number because you do not round off before you reach to the final answer. Let us see what we get. This answer, it must be 11,48 if what we did is correct. Okay, we're going to have 15 multiplied by 1,53,0612245, then plus half multiplied by negative 9,8 multiplied by 1,53,0612245, then we square. Let's see what we get. The answer is 11,48 meters. Can you see? So it is confirming that what we did is correct. You can see the answer is 11,48. Even this one, this 11,48 is rounded. The answer before it got rounded, it is 11,47. So rounded to into two decimal places. So it becomes 11,48. So it is like this. So it means the answer that we calculated first, it is correct. Although this is a very long method, this one was a short method which is straightforward. You get it. So that's how we get to solve that one. I'm going to give you another example. I must give you more examples since this lesson number 4, it is based on, we can start. It is displayed on your screen, question number 8. It is a very interesting question. It says that a ball is projected vertical upward with a speed of 10 meters per second from point A, which is at the top edge of a building. The ball hits the ground after 3 seconds. It is in contact with the ground for 0.2 seconds and then bounces vertically up, reaches a maximum height of 8 meters at point B. See the diagram, ignore the effect of friction. Okay, let us start by 8.1. Why is the ball considered to be free fall during its motion? Because what is a free fall? It is a free fall because only gravitational force is acting on an object. It is a free fall because only gravitational force is acting on an object. So that's why it is called a free fall. So whenever they ask you things which are based on definitions, be intelligent. You can write even the definition in an intelligent way. Whenever they ask you something in physics, why is that? You can even write the definition in an intelligent way. You understand? It's because only gravitational force is acting on an object. That's why the ball is considered to be a free fall. Okay, let us deal with the calculation. The question then says that calculate the height of the building. The height of the building. Then let me make a drawing so that you can understand what is happening. Let me make a drawing so that you can understand what is happening. Here is the drawing. Then the ball is projected up. It went up, then the ball hit the ground. When it hit the ground, it then returned to the air at point B. At first it was projected at point A. And then it went up by 10 meters per second. It went up then. You know at maximum it is going to be 0 meters per second. I want us to deal with this question, which I find to be very much interesting. Okay, let me give you the formulas. Vf is equals to Vi plus G, changing time. Then Vf squared is equals to Vi squared plus 2G, change in Y. The third one is G delta Y, which is equals to Vi changing time plus half G changing in time. 1, 2, 3. Then the fourth formula, delta Y, which is equals to Vi plus Vf over 2 multiplied by changing time. Okay. I think I've made everything to clamp in one place. Let me just draw my scenario on the side because I want to use it to demonstrate. Let me draw that building. Here is the building. A ball is projected up, the ball went up, the ball hit the ground and returned to point B. So this is point A. Can we say that point from the ground to point B is 8 meters per second. So that is the question. So the object went up by 10 meters per second. 10 meters per second. Okay. So let us do our theory application before we start to answer the question. The theory application, because the first question says calculate the height of the building. The question wants us to calculate the height of this building. When I was at high school, I used to think these questions, they don't make sense. How come? But now I understand. And because there was a time where I was not understanding, it becomes much more easier to explain because I know how it feels not to understand that particular thing. So let me bring it home and explain to you till you understand. Ladies and gentlemen, this ball was at point A, which is at the top of a building. Then it was projected up. what I know is that at the maximum height, the velocity of the ball is going to be 0 meters per second. 0 meters per second. 0 meters per second. That's what I know. Another thing, when the ball comes back to its in the same position when it is going down, even here at the edge of the building, when it is going down, it will be how much? It will be 10 meters per second. Since it left the edge of the building at 10 meters per second when it was going up, when it comes down, it will do what? When it comes down, it will move at what? At 10 meters per second when it reaches the exact position which is in the same level as the edge of the building. Can you see? There is something which is very important, which we are told in the question. The question then says that the ball hits the ground after 0.3 seconds. Let me, yes, not 0.3, 3 seconds. The ball hits the ground after 3 seconds. So, from this point, and the ball moved until it hits the ground. It took what? It took 3 seconds. Why am I saying 0.3? It took 3 seconds. So, we need to calculate the what? The height. We need to calculate the height of the what? The height of this building. Okay. I have always said to you that the only thing which will make us to be able to calculate the height is what? If we have this initial velocity and this final velocity. This initial velocity and this final velocity will give us ability to calculate what? Anything between them. We will never be able to calculate anything to do with these two. If we were not given any of the two. I said the confusing statement. This is what I'm trying to say. The only thing that will give us ability to calculate the height of this building is the velocity that is here at the edge and the velocity that is here at the edge. The second thing that will give us ability to calculate the height of this building, it is the time it takes for an object to move from this edge of the building and this edge of the building. You understand, right? You see this 0. We can never use 0, this 0 meters per second, to calculate anything to do with this building. You understand? This 0 has got nothing to do with the building. The only information that we can use to calculate anything to do with this building, it is what? It is the velocity that is starting from the edge of the building and until it reaches the ground. It is the time in which an object can move from the edge of the building to this ground of the building. You understand? So we can try to find. We have the velocity from the edge of the building. How do we know that we have? This velocity was going up. We're not interested. We're interested in the velocity of coming down. We know that when the ball reached this edge of the building, when it was going down, it moved at 10 meters per second. You know that, right? When it was coming down. So when it went up from the edge of the building, it was 10. When it returned back to the same height, it was 10. So we know that from this point it's 10. The problem, we don't know the final velocity. If we knew the initial velocity and the final velocity here, we're going to be able to calculate the distance of this building, because we're going to have initial velocity and final velocity. You understand? So we do not have. But what can we do? We can calculate the time it traveled, the time the ball traveled from this edge of the building to this, the ground of the building. You understand? We are told that the ball took 3 seconds to hit the ground. Do not get confused. This 3 seconds, it is the time the ball moved from this point going up until it returns, until it comes there. You understand? So what we need to do, we can just calculate the time it took for the ball to move from A to the maximum. And then it comes back. Then we can do what? we can subtract the time that we get from these 3. It means the time that we'll be left with, it will be the time from A to the ground. Let me repeat the same statement. It took 3 seconds for ball to hit the ground. You know what it means? What it means is that the ball moving from A until it hits the ground, it took 3 seconds. So what can we do? We can calculate the time the ball took to move from going up, reaching its maximum height until the edge of the building. We can calculate this time since we have the initial and the final velocity. When we have calculated this time, we can subtract the time that we will get from 3, then the time that will be left, the time the ball took to move from this point to this point. Then, since we will be having time from this point to this point, we can try to calculate displacement from this point to this point. You understand? I'm repeating that this initial velocity and final velocity will give you any information between them. So anything which is out here will not give you anything. That's why that 3 seconds will never give us ability to calculate the height of this building. You understand? That 3 seconds will never give us the ability to calculate the height of this building. The only thing that we need is the time that was moved from this point to this point, which we don't have. Which we can calculate the time which was moved from this point until it came back, then we subtract it from 3. Because we know from A until it hits the ground, it took 3 seconds. Okay, let me read the question for you again. It says that a ball is projected vertical up with a speed of 10 meters per second from point A, which is at the top of the edge of the building. The ball hits the ground after 3 seconds. Okay, so let us calculate the time from A to this point. The time it moved from A until the edge of the building. The time it moved from A until it came back to the same position. If we can know that time, we're going to subtract it from 3. Then we'll know the time that will be left, it will be the time from this edge until here. Then we'll be able to calculate the height of the building. Because the height of the building will be calculated by information that is between here and here. Initial velocity, final velocity. Time from here to here. You understand? That's how we move. So we can calculate the time which it took from here to here so that we can subtract it. We have a formula, number 1, which says Vf, which is equal to Vi plus G, changing time. Right? We're going to take up as positive, then up as positive. So the ball was projected up. It means the ball is going to move at 10 meters per second. That is our initial velocity. What about the final velocity? Remember that we are not calculating the time which it moved from here to here. We are calculating the time it moved from this point until it came back to the same position. It means we need to use 10 and 10. 10 as initial velocity and 10 as final velocity. That will be the time that an object will have moved between 10 and 10. Understand? If we were to use 10 and 0, that answer of the time from here to here, we're going to multiply it by 2 because we know the time it took from moving from point A, reaching maximum height, and the time it took from the top until it comes down, it will be the same. So, okay, it means final velocity, when the object is coming down here, 15 is positive. So, I mean, when the object is coming down, we took up as positive, meaning the object is going down, we're going to have negative 15. Then initial velocity will be 15 plus negative 9.8. Then we have changing time. Understand? We're going to have negative 15. Negative 15 whereby we need to multiply. We need to multiply 15. Oh, we are not multiplying, but we need to take the other 15 that other side. That means there we're going to have minus 15 minus 15. This 15 is going to come this side, minus 15, which will give us minus 9.8 change in time. So which will give us minus 30, which is minus 9.8 change in time. You understand? Then we divide by 9.8. We divide by 9.8. You need to notice that in mathematics we do not mark, in physics, what am I saying? In physics we do not mark mathematics. So these workings will not mark them. Here we mark the formula. We we mark correct substitution, we don't mark everything here, then we mark the final answer and the unit. So we don't mark math here. 9.8, then what's happening? 30, is it correct? We're going to have 30 divided by 9.8. We get a final answer 0.6. We get 0.6. 0.6. Okay, let me read the question correctly. I feel. Okay, so let us continue. We are going to use this formula to calculate the time the ball moved from point A and until it got to the edge of the building when it is coming down. So that we can subtract that time with 3, because 3 is the time it took from A until it hits the ground. So let us calculate the time. We're going to use this formula. Vf is equal to Vi plus G, changing in time. Up positive. We take up as positive. Final velocity, the velocity that will be here, because we want to use the initial velocity as the value that is here, then final velocity that is here, because this initial velocity and final velocity will give us the time between them. So we don't want the time between here and here. We want the time from here until we return to here. So we'll use this one as initial velocity and the one that is here as final velocity. We will get the time taken to travel between them. You understand? So final velocity is going to become downwards, it will be negative. Final velocity will be minus 10. Initial velocity going up, it will be 10. Plus 9.8 is downward, it's going to be negative 9.8. Then we have change in time. So the time will come this side, we're going to have minus 10, which is minus 9.8. Change in time, which will give us minus 20, minus 9.8, change in time. Then we divide by minus 9.8, we divide by minus 9.8. Our change in time is 20 divided by 9.8. That gives us 2.04. So the time it took for this ball to move from this point until it gets to the edge of the building, just before it starts to move down the building, just this very top edge, it will take 2.4 seconds. So now we will eliminate this part. We will eliminate that part. It means that the time it took for this ball to move from the edge of the building to the top of the building, we are going to say 3 minus 2.04, meaning that changing time, our changing time is going to be 3 minus 2.04. That will give us a 0.96. So we're going to use 0.96 as what? As our time. 0.96, it is going to be what? Our time at which the object moves from this edge until this point. Okay, so now let us calculate the velocity at which not the velocity, the height of the building. So this is the first step. Then we know that, let me note it here. Changing time is 0.96. Then I'll also note the changing time of 2.04, which we subtracted from 3. Then if we want to calculate the distance of the building, we will use I will still use up as positive. Which formula for time, initial velocity, and displacement is this one? Meaning that I can say that delta y is equal to initial velocity multiplied by changing time plus half gravitational acceleration change in time squared. You understand? Then what we're going to do, we're going to have We're going to have changing time, which is what we are. We're going to have delta y, which is also initial velocity, which is going to be 10. 0.96 plus 1 over 2 down 9.8, it is positive 0.96, then we square. Let us see if there will be a change. We're going to have 10 multiplied by 0.96 plus half 1 over 2 multiplied by 9.8 multiplied by 0.96, we square 8. See, this time we get 14. 14 to my left.